Welcome back to MACSVEDA. In this session, let us start with introduction to circles. First of all, what is a circle? You all know what is a circle, but how to formally define a circle? Let us see this. Now consider this set of points and the fixed point O. Now take any point A, find the distance of A from O. The distance is 4 centimeters. Take another point B, the distance from O is again 4 centimeters. Another point C, the distance from O is 4 centimeters. Another point D, the distance from O is 4 centimeters. Another point E, the distance from O is 4 centimeters. So what you understand? All these points are equidistant from a fixed point O. So let us define circle. Circle is set of points in a given plane which are at equal distance from a fixed point. So this is how we define a circle. It is set or collection of points in a given plane which are at equal distance from a fixed point. And this fixed distance is called radius. Okay, and of course that fixed point is called center. Now, how many radii can we draw in a circle? See here, if you want, you can draw many such radii joining a point on the circle and center. So we can draw infinitely many such radii. All these are radii. Very good. Now let us understand few more elements of circle. Let us consider two distinct points, say C and D. Now let us join the 2 points. What is this line called? So it is a line segment, and such a segment is called a chord. So what is a chord? A line segment joining two distinct points on a circle is called chord. And again, how many chords can we draw in a circle? We can draw infinitely many such chords. Just join two distinct points. Take any two distinct points, join them, you get chord. Any two distinct points you take and join them, you are going to get a chord. Wonderful. So we can get infinitely many chords in a circle. Fine. Now let us draw a chord passing through the center of the circle. Now this is also chord joining two distinct points on the circle, but it is passing through the center of the circle. Such a chord is called diameter. What we call it? We call it as a diameter of the circle. And if you observe, OP is radius, OQ is radius. So diameter is 2 times radius. Diameter is 2 times radius. Please note that. So what is diameter? A chord passing through the center of the circle is called a diameter. Now how many such diameters we can draw in a circle? Of course we can draw infinitely many such diameters. Just need to draw a chord passing through the origin. We can draw infinitely many such diameters. Got it? Very good. So we can have infinitely many diameters. So we can have infinitely many chords, we can have infinitely many diameters. Wonderful. Now let us draw a line intersecting the circle in two distinct points. Now this line intersect 2 points. What do you call such a line? Such a line is called secant. And if you observe, every secant contains a chord. Okay, first of all, let us define secant. A line intersecting a circle in two distinct points is called a secant. And secant always contain a chord. Now let us draw a line intersecting circle in one and only one point. So here this line intersects the circle at only one point, and such a line is called tangent. A line in the plane of a circle intersecting at one and only one point is called tangent. The point where the line touches the circle is called point of the contact. So here A is the point of contact. Now let us answer the following questions. First one, how many tangents can we draw in a circle? Or how many tangents can a circle have? So you can have as many tangents as possible. Okay, we can have many tangents possible. That is, a line intersecting a circle at only one point is called tangent, and we can draw infinitely many such tangents. So the answer is a circle can have infinite tangents. The next question, fill in the blanks. A tangent to a circle intersect it in how many points? A tangent to a circle intersect it in a only one point. We can say one and only one point. A line intersecting a circle in 2 points is called what? A line intersecting circle in 2 points is called secant. What do you call it? Secant. And of course, the chord is part of a secant. Every secant contains a chord. A circle can have how many parallel tangents? So this is a tangent. You want another tangent which is parallel to this, and that is only one possible. So we can have two parallel tangent at the most. The common point of a tangent to a circle and the circle is called what? That is, point where the tangent intersect with the circle is called what? That is called point of contact. Clear? So this is about the introduction to circle. Let us consider the following theorem. A tangent at any point of a circle is perpendicular to the radius through the point of contact. Consider the circle. Let us take a point A on the circle. Consider a tangent passing through A. Let us call it as L. So this L is tangent passing through the point of contact A. Now the radius through the point of contact, what is it? OA. The radius through the point of contact is perpendicular to the tangent. So we need to prove the radius through the point of contact, that is OA is perpendicular to the tangent line L. So this is what we need to prove. So for this, let us take a point B on the tangent. Now I want to know what is angle AOB. Now consider this distance from O to B. Now let us consider this distance from O to B. See, obviously OB is larger than OA because up to OQ it is radius. So it is more than radius, so obviously OB is larger than OA. Not only OB, you take any other point, say C, you take the distance from O to C, even OC is larger than OA. You take any other point, say D, and even OD is larger than OA. Now you know that the shortest distance from a point O to a line L is called what? What is the shortest distance from a point to a line? It is perpendicular. So out of all these distances, obviously OA is the shortest distance from O to this particular line. So definitely OA is perpendicular to the line segment L. So if you want to know what is angle OAB, even that is equal to 90 degrees. So what we proved? Radius is perpendicular to the tangent. So we can remember this theorem in short like this. What is this theorem says? Radius is perpendicular to the tangent. Consider the following problem. If TP and TQ are the two tangents to a circle with center at O. So we are having circle with center at O, and here TP and TQ are the two tangents. So TP and TQ are two tangents. So that angle POQ is 110 degrees. So angle POQ is 110 degrees. And we need to find angle PTQ. We need to find angle PTQ. So we need to find this particular angle. Now consider this quadrilateral OPTQ. It is not rectangle, it is a quadrilateral OPTQ. So in this quadrilateral, we know angle POQ is 110 degrees. Now you know OP is perpendicular to the tangent line because radius is perpendicular to tangent line. So what is angle OPT? Because OP is radius which is perpendicular to tangent, therefore angle OPT is 90 degrees. So angle OPT is 90 degrees. Then what about OQT? Same observation. Radius is perpendicular to the tangent. Therefore, angle OQT is also 90 degrees. So we know angle OPT is 90 degrees and angle OQ2 is also 90 degrees. So in the quadrilateral, we know three angles, 90, 110 and 90. We need to find the fourth angle. But you know the sum of all angles of quadrilateral is 360 degrees. So angle POQ plus angle OPT plus angle OQT plus angle PTQ is equal to 360 degrees. Substitute the values. Angle POQ is 110, angle OPT is 90, angle OQT is 90 and angle PTQ we need to find is equal to 360. So adding them we get 290 plus angle PTQ is 360 degrees. Therefore, angle PTQ is 360 minus 290, which is 70 degrees. Next problem. A tangent PQ at a point P of a circle of radius 5 centimeters meets a line through the center O at point Q so that OQ is 12 centimeters. Find the length of PQ. Here tangent PQ meets the circle at point P and the radius of the circle is given as 5 centimeters. So the radius of the circle is 5 centimeters. Because P is point of contact, therefore OP is same as radius, therefore OP is equal to 5 centimeters. Now this tangent PQ meets a line through the center. This is the line through the center. So this tangent PQ meets the line through the center at Q. So that OQ is equal to 12 centimeters. Here this OQ is given as 12 centimeters. Then he is asking you to find PQ. See here, first thing which we know is radius is perpendicular to tangent. That means this angle is 90 degrees. Therefore, the triangle OPQ is right angle triangle. Now in the right angle triangle, two sides are given. We just need to find the third side. So we use Pythagoras theorem. So by Pythagoras theorem, we are having OQ square is equal to OP square plus PQ square, where OQ is 12, so OQ square is 12 square, OP is 5, so OP square is 5 square plus PQ square. So we need to find the value of PQ. Now PQ square is 12 square minus 5 square. So we have PQ square is equal to 144 minus 25. Therefore PQ square is 119. So what is PQ? Under root 119 centimeters. Next problem. From a point Q, the length of the tangent to a circle is 24 centimeters and the distance of Q from the center is 25 centimeters. Find the radius of the circle. So here from point Q, the length of the tangent to the circle is 24 centimeters. So QP length is 24 centimeters and distance of Q from the center is 25 centimeters. That is QO is 25 centimeters. We need to find radius of the circle. So let us solve the problem. Okay. Now here we know that radius is perpendicular to tangent. So clearly angle OPQ is 90 degrees. Therefore triangle OPQ is right angle triangle. So in the right angle triangle, we know two sides. We just need to find the third side. So by Pythagoras theorem, we are having OQ square is equal to OP square plus PQ square. Here OQ is 25, so you get 25 square is equal to OP square. We need to find it. PQ square is 24 square. So we get OP square is equal to 25 square minus 24 square. 25 into 25, 625 minus 24 square is 576. So upon simplification we get 49, that is 625 minus 576 is 49. So what is the value of OP? Under root 49, that is 7 centimeters.